Hi, everybody. I would like to speak to you today about the relationship between robotics and AI. The topic of my presentation now is about robotics and AI back to reality. I think that everybody knows about what is robotics today in the industry. Robotics is in action in the automotive industry, in food industry, and there are a lot of development today which are very, very active. But I would like to emphasize today on advanced robotics. Advanced robotics means what are the last results of the research today. And I would like here to show you two different examples. One on the left is a very well-known video done by Boston Dynamics that shows that it's possible today in robotics to make such a spectacular motion for a robot, for a humanoid robot. On the right, you have another robot which is much more effective, if I can to say that like this, in the sense that this is a humanoid robot in production. This is not the future of the robotics, but this is today. Okay, and then I would like to comment and to compare the progress of the robotics with respect to the progress of artificial intelligence at large. And I compare here the capacity, the performance of a computer to play chess or to play Go here in this example. And as you know that there are software that are able to compete with the best player in Go. And on the right, I show you again, next stage, then from the Kawada Robotics, that shows that today the robot can be in production. It appears that the progress in AI are spectacular, are rapid, and I draw here just for the feeling an exponential curves. If I compare to robotics, the progress are much slower. We are expecting a lot from robotics, but it appears that the progress are slower. And it is important to understand what is the difference of dynamics in the development of AI from one side and robotics from the other side. Both the success of robotics and AI are mainly due to the progress in the hardware and in the increasing power of computers, and also in the development of research in providing new algorithm and new associated software. Then in some sense, these progress are mainly technological, hardware, and scientific in the development of new algorithm. But why there is such a difference between robotics and AI? And I would like to try to understand that question. The central question is the question of reliability. And I would like to develop this issue in this presentation. Everybody knows that it's possible now with your cellular phone to use an application that gives you in the library of photographs you have to select some people, and then the face recognition is very famous, and it's working very, very, very well. Very, very, very well. What does it mean? That means that it works well in general. And I would like to just to emphasize, and I think most of you knows this paper where you have two similar image of a bus, but just by tracking some intermediate data structure, it's possible for the software to make an error and then to consider the bus as an ostrich. Okay, and we know that the software are quite fragile, and if you apply that kind of software here, give me all the faces you have in this picture of several people, and you know that there may be some bias if your software has been trained from data set including only white people. The black people will not be identified, and all of us knows that. But in some sense, this is not a serious problem in the sense that at least on your cellular phone, that kind of software, you evaluate yourself the quality of the software. That means that if there is a confusion between the picture of your brother and the picture of your uncle, it's not very. There is no major consequence. And in fact, we may see that we have become accustomed to using software that does not work. What I mean by does not work, that means that the percentage of success for this software is not 100%. Okay, and we accept that. Okay, everybody has used already some other application like I don't know, Waze when you are driving your car, and it's very, very useful. But sometimes you see obviously that there are some error, but these error have no consequence. If you consider now software which are not reliable on the humanoid robotics or on robotics at large, this is what happens. That means here, if the software, the quality of the software is not 100%, the validation of the software is no more by you on your cellular phone, but by the machine. And in that case, you can see the consequence of the mistake of the in the software you are considering. Here is the florilège, of course, from the DARPA Grand Challenge on humanoid robotics in 2015. Okay, there were some success, but this is just a florilège to illustrate what I mean by saying that if it's not possible in robotics to use software which are not guaranteed to work. Okay. And then what is the challenge, in fact? The challenge is that robotics is not pure information processing. Robotics is challenging the physical world. And what we have to understand is that robots are moving machines. And okay, I don't want to display all the application domain in medicine, space transport, services, industry, defense, agriculture, etc., etc. Okay, but robotics is concerned by machines. And what we have to understand is that the final objective of the robotics is to be able to program the machine at the level of the task to be performed. And then in some sense you are saying the robot, take a glass. And you don't want enter into the detail. That means that this is the software that has to solve the problem. And in fact, the instruction you give is in the physical space. But of course, the access to the physical space by the machine or by you, because this is the same problem as for the humans, is that you access the physical space through the sensory space, and it's possible to act via the motor spaces. And then, in fact, the main issue in robotics is the problem of the space inversion. That means the instruction is given to the machine in the physical space, and all the machinery inside the robot has to transform these instruction in the physical space in a meaning in the sensory space. What I have to do to pick a glass on the table, I have to see the glass and I have to move my arm, to move my hand to pick that. Okay, and this is what we can call motion intelligence, because the concept that makes the link between the physical space and the sensory motor space is the motion. Okay, and then there are a lot of progress in the, you have seen some florilege about the mistake in the DARPA Grand Challenge, but it's possible to see also some success. For instance, if you are looking at the video on the right, the robot HRP2 is picking an object on the floor, and as you can see, to perform this action, all the body is contributing to the action, not only the arm, but also the legs, if you want. Okay, then to summarize, my purpose today is to truly to emphasize on the certification issue, which are very, very critical in robotics. And I would like to take as an example this very recent report, and this is September 2020, which has been submitted to the American Senate. And this final report is about the design and the development and the certification of the famous aircraft Boeing 737 MAX. And it appeared, of course, this is a huge report, but to summarize with respect to my purpose today, is that one of the main reasons for the accident is a defect of certification. Okay, that means that the design was perfect, everything was very, very nicely designed, but Boeing misses the phase of certification, of a serious certification, and you can see the consequence. Then that means that using software which are not certified in some sense in robotics is very, very critical. And then as a consequence, I would like perhaps to redefine the notion of autonomy. What is an autonomous robot? An autonomous robot, I will say that this is an automated machine within its Umwelt. And in some sense, the Umwelt is subject to standard. The machine is subject to standard that define an environment that has to be closed. That means that in this environment, that means that in the use condition, you define the use condition, and everything has to define something close. And a robot that will take a decision with code outside its Umwelt will be a machine out of order. Otherwise, this is truly responsibility of the roboticist not to put on the market a robot that can. And then this is one of the main difference and one of the challenge today for robotics is that robotics impose not putting on the market machines that have not been proven safe and reliable. And with respect to the modern AI, and I am thinking mainly of this very promising method on machine learning at large and deep learning, we know that this technique suffers from property of explicability, for the property of the robustness, etc. And this is truly a challenge for research. But this is one of the conditions for the roboticists to use that kind of approach in robotics, because the certification is truly a critical issue. I thank you for your attention.